Hey students, welcome to another Mr. Ness screencast. Today's aim is the demographic transition model, and here are your objectives. Please pause the video, look them over, and get ready to copy some vocab terms and take some notes. Your first term today is model. Models are theories or hypotheses that try and predict how a process will occur. Models are predictions, so they're not always true, and they don't accurately predict every situation. But they provide a good guess for how things might unfold, and they're often correct. We're going to be looking at many different models throughout the year, and you've actually already looked at one of them, the gravity model. There we go. Remember, that was the model that predicted that places that are near each other will be more similar to each other than places that are far away from each other. The AP Human Geography exam loves to ask you about models, so you need to make sure that you know your models well. And another thing that the exam loves to ask you about is contradictions to each model. These are the situations that prove the model wrong. They are the exceptions to the rule. To go back to the gravity model, we saw that various recent technologies, like the airplane and the internet, cause a phenomenon called space-time compression, which decreases the time it takes for something to move through space. Space-time compression contradicts the gravity model. It shows that the gravity model is not always true, because places that are far apart might actually be able to communicate very easily now with these technologies. All right, to sum up, models are predictions that are usually true, but not always. You need to be familiar with the model itself and its contradictions. And the model that we're going to look at today is called the demographic transition model. Out of all the models that we're going to look at this year, the demographic transition model is the one that I find the most incredible. The demographic transition model, or DTM, predicts that populations will undergo specific demographic changes, that means changes related to their population, as they industrialize and develop economically. Remember this term development. You learned in a previous lesson that development is a measurement of healthcare, wealth, and education in a country. So the demographic transition model predicts that as a country develops, a number of different changes will occur in its population. There will be predictable changes in birth rates, death rates, rates of natural increase, and total fertility rates. And the most important of these demographic changes, the one that I want you to remember over all the others, is that the model predicts that there will be a decrease in the total fertility rate, or TFR, as a country develops. Remember, the TFR is the average number of children that a woman will give birth to in her lifetime. All right, let's sum up this model. As countries develop, women will have fewer children. Try saying that. As a country develops economically, women have fewer children. This is what the model predicts in a nutshell. And what I find so amazing about this model is that in most cases, no one is forcing women to have fewer children, they just choose to do it. And this change almost always happens. It's pretty amazing. On your vocab sheet, I've left some room for you to add in contradictions to the demographic transition model, but we're going to do those later. I'm not going to discuss them in the video. So for now, you can leave that portion blank and we'll return to it later. All right, take a look at this graph, which shows the demographic transition model in visual form. I want you to be able to read each part of this graph. The first thing to notice is that the model has 5 different stages. Stage 1, Stage 2, Stage 3, Stage 4, Stage 5. And each stage represents a different level of development, where 1 is the lowest development and 5 is the highest development. The second thing to notice about this graph is that the demographic trends indicated by these 3 different lines are very important to understand. The yellow line shows the birth rate. The green line shows the death rate, and the blue line shows the total population. Be careful with this blue line, total population. It is not the same as the rate of natural increase. The rate of natural increase is the rate of population growth, the speed. whereas this blue line just shows the total population. All right, now let's see how to find the rate of natural increase in each of the stages. You might remember that the rate of natural increase is the birth rate minus the death rate. So on this graph, the natural increase rate is shown as the space between the yellow and green lines. For example, in stage 1, there's no space between the green and the yellow lines, so the natural increase rate in stage 1 is effectively 0. That means the population is not growing. In stages 2 and 3, there is a lot of space between the two lines, the yellow and the green. And that means that the rate of natural increase is large in those stages. The population is growing rapidly. In stage 4, you can see that the space between the green and yellow lines is small again. So the population has slowed down or even come to a stop. Notice, in stage 4, the blue line, the total population, is high, even though there's almost no population growth occurring in this stage. This is why I want you to be careful not to confuse the total population, the blue line, with the rate of natural increase, the space between the green and yellow lines. In this stage, there are a lot of people, but the population isn't growing, which means that this total number of people will not keep increasing. All right, just to sum up, let me go back. In the demographic transition model, there are 5 stages, with each stage representing the level of development of a country. Countries that are not very developed, like Niger, for example, are in the earlier stages, like stage 2. Countries that are very industrialized and developed, like Japan, are in the later stages, like stage 5. In each stage, demographic trends, the population trends, are behaving in predictable ways. All right. I hope you enjoyed learning about this really cool model. Now it's time to review the objectives, and if you don't know the answer to any of them, rewind the video and look again. See you in class. Bye, students.